All right, so this is a little example I usually start with little Friedrich from Germany. He turned out to be Friedrich Gauss, one of the best mathematicians of all time, is challenged with adding up the numbers from 1 to 100. He figures out this pattern. The 1 plus 100, the 2 plus 99, they all add up to 101. And then he realizes that it's 50 sets of 101, and therefore it's 50 times 101, so it's 5,050. Well, we're going to use that same thing to add up a sequence. No, because when we're adding them, we call it, it's not a sequence anymore. Then if we add them all up, it's called a series. Okay, so that's the two numbers for this unit, is the sequence and series. We started with sequence. Now we're moving on to series, where you're going to add all these numbers up. Okay, so back to, he took the first number and the last number, and he added them up. And the last number, the a sub n thing, do you remember that deal where we go a plus n minus 1 times d? And then we got to do half of those. So take the number of numbers we had and divide by 2. And there is your formula, except I'm going to clean it up for you. Everybody write this down. N over 2 times 2a, because a plus a is 2a. Write this down. Actually, write it on your iPad. This is a critical formula. Plus n minus 1 times d. Now let me just show you, it also works for weirder situations. We start with 8. And we skip every other number. 8, 10, 12, 14, ... And we do that for 60 numbers. 60 terms. Use the formula I just gave you and figure out what it adds up to. A is the starting number. If you forgot why there's two A's, it's because we had the starting number, and then the ending number had an A in its formula too. That's where we got the 2A. But since I've already showed you where this came from, now you can trust it. Drew, can you tell me what numbers to put where?
For n, you can put in 60.
60 here. Change colors. Okay, and then what?
Put 60 for the n on the inside.
Yes, you do. That is the most, like, people hitch on that one. Like, wait a minute, is that the same n? Yep, n has to be n.
Is a going to be 2?
Nope. The common difference is 2. What's a? You got to tell what you start with. So 60 divided by 2 is 30, times 2 times 8 is 16, plus 60 minus 1 is 59 times 2. Well, that's like 60 minus 2 is 58. 58 plus 16, 60, 74 times 30. I think it's 222. Did anybody verify that? 210 minus 3 is 12. Okay, obviously I did it wrong. Thought I had it. Okay, 16 plus 59 times 2 is definitely not 58. Yep. 59 times 2 is where my major mess up was. Okay, so 59 times 2 is, that's like 60 times 2, which is 120, but then take away 2. 118? All right, and then I'm going to add 16, so 120, 34, 134 times 30. Can anybody verify that? All right, and who's got the actual final answer? 420? Oh, 40, 20. 4020, raise your hand if you had 4020 before I even said it. Okay, awesome. That's what this sequence of 60 terms would add up to, 4,020. Yes?
So, at the start, I did a little different. I got rid of the 2 from both sides of the equation because I needed a parenthesis.
Oh, you like sort of like you have a 2 here, and so you thought, I'll just factor out that 2 that was here and here, and that works, but only when your D is 2. If it happens to be counting by 2s, then you're right, and you still get the same answer, and it's a lot easier. Good call. And in the end, what you did was factor. And of course, if you can factor it, you should. He noticed there was 2s here and here, and then it was dividing by 2, so yeah, that could absolutely cancel. Okay, so let me give you one more without the formula this time. Hopefully you can recall it. Remember, it's n over 2, and then you have 2 a's at the beginning, and see if you can finish it, okay? So we're going to start with 10, and then we're going to count by 5s. And we're going to do that, let's make it 20 terms. Figure out what that would all add up to. I'll pause for a sec. You're finding a series here. It's where you have a sequence of terms and you add them all up. Pausing. Did you start with, there were 20 terms, so 20 divided by 2. Raise your hand if you knew that was part of the formula. Okay, good. Sophia, can you tell me how to do this inside part? 2a, in this case that is? Excellent. This is our n minus 1 part, which in this case is 20 minus 1, which is 19 times 5, the common difference. All right, awesome. This is where D goes. And this was 2a's. All right, cool. And this was n over 2 at the beginning. All right, awesome. Then 19 times 5 is pretty much 20 times 5, which is 100. But then you take off 5, so that'd be 95. And this is 20 plus 95, 115, and then this is 10. So 10 times 115 is 1150. Raise your hand if you had that before me. Okay, awesome. So I think you get this now. That's fundamentally the main thing about series is how to add them all up. Okay, but the only other thing is how to write them. The same exact series, the same series here, could be displayed with this sigma thing. And then if I want 20 terms, I'd say from 1 to 20. And then we put a little term generator right here. So you can stick in a 1 and you'll get 10. You stick in a 2 and you'll get 15. I'm going to give you a hint. It's not just 5n. But do you get the difference here is 5 each time? They're adding 5 each time? Okay. So there is a 5n in it. 5n plus 10? No, because then when I put in a 1, I will get 15. I think 5n plus 5?
Yeah.
Let's see. We stick in 10, we're supposed to get... No, we stick in a 1, we're supposed to get 10. Put in a 1, and I get 10. Cool. I put in a 2, and I'm supposed to get 15, and I get 2 times 10 plus 5. I do get 15. Yay, I found it. So it was 5n plus 5. That right there is probably, in my opinion, one of the trickiest parts, is figuring out how to make that. Because anybody can say from 1 to 20. Duh. It's 20 things. You still always start with 1. I'm going to repeat that. Always start with 1. You could start with 0. It will make your life 10 times harder. Don't. Just always start with a 1 on the bottom. And then if you have 20 terms, say from 1 to 20. This weird-looking Greek letter, it looks like kind of like an E. It stands for summation. Sigma is the official name for it. So here's a great way to get this. The hard part. Do you remember me telling you that the any term thing was like a big deal? A sub n is a plus n minus 1 times d. If you put this part of it right here, it will work. Let's do it for this problem. What was our a in this problem? Hello, what was our A in this problem? 10. So we have a 10. But you have a plus 5, Mr. Zipper. Wait for it. N minus 1, leave that as an N, because we need a variable in here. Okay? And then times D, which is, what is our common difference here? 5. Guess what you get when you simplify this down? 5n plus 5. Now, if you want to just figure it out for yourself on each problem, you can, but I wouldn't. I would just use the any term formula, this guy right here, and I put that right in front of the sigma, and then just simplify it down. Okay, so let's start with another nice simple sequence. We'll start with 20, and this time we will subtract 3 each time. 20, 17, 14, ... I think you get the idea, right? Now, you got to tell the person when to stop. And I'm going to say we're going to do 10 terms of this, and then add them all up. What if the numbers go negative? It's okay. You still add them all up, including the negatives. The negatives subtract away from your total. All right, so don't add them all up for me. Make a sigma for me, which is really make a summation for me, which is really make a series for me. So there's some alwayses and nevers in life. What did I say to always start with here? 1. And how many terms do we want? So it goes 1 to 10. That part's easy. And then I said you could figure out like something you want to put here, like 7n, but it's not 7n. But I said there was the easy way, which was to put the any term formula there. Would everybody try to remember what a sub n is and stick it right there? The any term. Nick Vose, what do you get for a sub n?
I got n minus 10.
Okay, but what's that formula for a sub n again?
A plus n minus 1 times d.
Excellent. Now let's stick in the numbers and see if that comes out to what you're thinking it will.
So 20 for a.
20 plus, actually leave it as n minus 1, because we needed a variable in there. If there's no variable here, you're doing it wrong. But then I can put in the d. What's the d?
-3.
Yep. Now let's just distribute this thing out. I got 20 plus negative 3n plus 3. Oh, negative 3n plus 23. That's what goes in front of the sigma. So I'm going to just bring my sigma down here again. From 1 to 10. There. That's a term generator. It'll tell you the first 10 terms, and then you can add them all up using a completely different formula. But let's just make sure it gets you the first term right. Do you get, if I did it right, when I stick a 1 in, I'm supposed to get 20. Sticking in a 1. Huh, I get 20. Yes?
Do you do the same thing with the geometric sequences, except you use the other formula?
Pretty much, yes.
And then what about with the other formula?
I know you want to learn geometric today, but I'm not teaching geometric today. We have to have something to teach you on Tuesday. So let's talk big picture here. So we have 1 day left, and she's asking about that stuff, which is when they are geometric kind, where you like start with 2 and then you times by 3 each time. Completely different formulas, but similar way that you would make the sigmas. Okay, so these have all been arithmetic We're saving geometric for Monday. And then Tuesday, sorry, Monday we don't have school. So we do Tuesday, geometric. It's the last new thing. Wednesday, we review for a little quiz on the stuff I've just taught you. Okay? And we start review for the final on Wednesday. Then Thursday, you have a quiz on this, like what we just did today. This is like half your quiz. If you understand everything I just taught you right here, this is like more than half, actually, of the quiz. So it's kind of like a test, but it's not a test because it's only on a few days of material. So, okay, so that'll happen on Thursday. And some of you will finish in 15 minutes, you'll be done. And then you'll start working on the review for the final also again. So we're starting reviewing for the final Wednesday. By Thursday, you'll have this packet, which is a whole bunch of practice problems on what we've learned this semester. Then Friday, we go through the packet again. I basically go through the packet, answer questions, how you do this kind, how you do that kind. And then we get the same thing on Monday and Tuesday of the following week. Review. And then the big hoo-ha final for you guys will be on Wednesday. And then Thursday, you won't even have this class. And then Friday, you don't have school either of that week because it's last day of the semester. So teachers get to crunch grades. What?
Because it's the last, it's 4, 5, 6 hours.
Yeah, so it's finals for hours 1, 2, and 3. They're long periods, yeah. So hours 1, 2, 3 is Wednesday, 4, 5, 6 is Thursday. You guys don't have school on Friday, I have work day. To crunch grades. Okay, so let's see if you if you've been picking up what I've been laying down. Ready? So it's not little Friedrich this time. It's little Ashina. They're trying to keep her busy with add up all the even numbers. Add up the first 100 even numbers. Okay, everybody, go. The first 100 even numbers. Add them all up.
0 count. Well, since you add 0.
If you were going to add it, it wouldn't matter. But let's start with 2. Let's start with 2. The first 100 even numbers. There's a formula for that, and if you don't have it by now, you have no chance. Stellar Scott, can you tell me what that formula is?
A plus n minus 1 times d.
That is the one that'll tell you in any term. That is a great formula, but it's not the one that adds them all up. The one that adds them all up is the one where you start with the first term and then the last term, and so then you got A plus all of that. You know what I'm talking about? Just ringing a bell? A plus all of that, and then you got to cut it in half. N over 2 is that ring a bell? Okay. Okay, so there it is, except I'm going to make it a little more formal. N over 2 times 2a plus n minus 1 times d. Now, I know, it's a pain in the butt to memorize, but if you have it memorized, you'll know how to use it way better than if we probably will give you a sheet full of formulas, but if you've got them memorized, it's way better. So, little Ashina, can you tell me what I should put where in this formula?
Put 50 in parentheses.
So you're doing 100 divided by 2 in your head, okay, and then?
And then 2 in for A.
2 goes in for A, and then?
And then 2 in for D.
And in this case, we want to put the N in there too. So what's the N?
100.
Yep. So you already did this part was 50, and this part's 4 plus 99 times 2. Have you done that yet?
You can do the factoring. 'Cause there's
Ooh, yeah, you can do the little factoring trick. I like it. Let's do it.
That's what I did.
So if we factor out the 2 from this part, I'd have 2 plus 99. And then this part has a 100 divided by 2 in it. And then our 2's can cancel. Nice. 100 times 101. And I was thinking, wouldn't this just be twice as big as that other answer? Because you have 100 terms, but they're going to 200 instead of to 100. And so I was, anyway, but it turns out I multiply by 100 and I get 10,000, but then I have an extra 1 times 100, so then that's a 1 right there. 10,100. Raise your hand if you had that one right. Sweet. Okay. Part B of the test is, can you write me a sigma for that same scenario? 2, 4, dot, 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 100 terms of that. Write me the sigma problem that adds up the first 100 terms of that. Okay, Naomi, the sigma part's actually pretty easy. It's the thing after the sigma. Can you tell me the sigma part?
100.
All right. I always go from the bottom up on these, but you are right. And then this part, if you try to just divine it in your head, it'll be difficult. If you just use the term finder formula, not the one we just used. The one we just used had the n over 2 in front, not that one. It's tempting. It's not that one. This is the normal term finder, the any term formula. So I don't need the a sub n in it. I just need the a plus n minus 1 times d. And in this case, that is 2 plus n minus 1 times 2. So 2n, oh my gosh, it's just 2n, isn't it? Because you got a minus 2 and a plus 2, so it's just 2n. Now you could have actually divined this one in your head pretty easy, but I don't recommend that you do that as a general rule. I recommend you do the any term formula right there and simplify it down. And what does this do again? Well, if I stick in 1, I get 2, and that's the first term. And if I stick in the next number between 1 and 100, which is 2, then I get the second term, and it just basically makes a list of all the terms. A completely separate formula is this one. And I've got it memorized. Maybe you do, maybe you don't. Okay, and then the only new thing I have left to teach you is the same exact thing, except what if the problem isn't arithmetic? What if it's like going 2, 4, 8, 16, 32? That kind of problem. All right. So, I feel like you've got this. Let's go look at your homework. Miscreants. Okay, so on the green page, do problems 5 and 6. This is me cutting your assignment down to a much more reasonable size.
God bless you, Mr. Sugar.
It does help you focus on small but doable assignments. Let me say that again. 3 and 4 are assigned on this page. I know it's weird. 5 and 6 was on the first page. The second page is 3 and 4. Probably never happened before. And so I didn't. Now on the third page, I recommend 9, 10, and 11, the first 3 of them. And on this page, I recommend the middle 2, 17 and 18. And that's it. I think you should be able to finish before you leave today and be in really good shape.
Oh my gosh, we have so much time before the class ends.
I know, it's weird, isn't it?
Yeah.
Ooh, I should do something to keep Owen busy. Owen, would you go back in the corner and add up the numbers from 1 to 100?
I
You could.